let's just recap. Let's just do one question as a recap. I was looking at a good one a second ago. Page one. Oh, where's it gone? See, did I delete it? One sec. Yeah, this is the one, sorry. 3 plus... no, I'll just pick one that's a bit more straightforward. Even more straightforward than that. Yeah, so let's just do one. Sorry, question 3, part C. It's probably the hardest of that type. So do you remember how we'd go about this?
Not particularly, no. Do we need to look at the 4th row in the triangle?
Yeah. How would you do it with your calculator?
C something.
Yeah. You've forgotten. Hang on.
Yeah.
Okay. There we go. So, binomial expansion in general. So this is to the power of 4.
Yeah.
And so I write it as 3 brackets and 1 under the other. So, like that. So it's just a bit easier to get the pattern. So first one will be 4C0. That'll give us that coefficient. Second will be 4C1. What is the next one?
4C2.
Yeah.
And 4C3.
Yeah, and silly mate, it's actually 4C4 as well. So when you expand something that's a square bracket, you get 3 terms. Yeah, so it's always one more. Second one, do you remember that one?
No, I can't remember, sorry.
So this will be 3 to the power of 4, 3 to the power of 3.
Right.
Keep going.
3 to the power 2.
Yeah.
3 to the power 1, and then 3 to the power 0.
This one?
Is that the 2x to the power 0?
Yes, don't forget the minus.
Minus 2x, sorry. And then minus 2x to the power 1. And then...
Yeah, all the way down.
Up through 4.
That's it. And you'll add all those. So let's try this one here in the middle. Hang on, let me think. Now try this one, the second last one. Minus 2x to the 3. Try that one. Do you have your calculator?
No, I haven't.
Say it again, sorry?
I haven't got my calculator with me.
Conall.
I know.
Okay, so I'll use this one. Okay, so this second last one, so exactly how I've done it there. 3 brackets. First one is 4. Shift divide gives that C, NCR. 4C3. Next bracket is 3, and then to the power of 1. Ooh, I didn't know that would happen. Okay, 3 to the power of 1, and then minus. How do I deal with the x?
Shift.
Just leave out the x.
Oh.
So leave out the x to the power of 3. So that's it exactly as I've written it down. Press equals minus 96. And so what will the power of x be for the third one?
Minus 96.
So it'll be x to the power of what?
2 squared.
This one will be squared.
Cubed.
Yep, that's it. So you would do that for each of these. The first one is always 1. Anything to the power of 0?
It's just 1.
1. And 3 to the power of 4 is 81, I believe. So you'll get 81. The second one will be negative minus 4 times all of that. Okay, so you'll get a bunch of stuff there. And we just got the hardest one. Answers 3 part C. So the first thing is 81. Then minus 21. 216x squared minus 96x cubed, and then last one plus 16x to the 4. So you just put each of those into your calculator one at a time. Leave out the x because you can't do that, and then just remember to write the x in after it with the correct power.
Okay.
Any questions there?
No, it's jogged the memory of it.
Okay. So did you want to take that down? You're all right.
No, it's all right.
Okay. So let me go back now. So there's a harder type of question which we also need to do. So this is the next thing. Okay. How do I do 4A part? Yeah, question 4 part A. Yeah.
Including term x3. So you need to do the is it because it's to the power of 8, you do 8c.
Yeah.
And then 0. And then the next one is just 1 to the power 8, and then plus x to the power 0.
Yeah.
And then the next line is 8c1. And then
And you can go down if you want.
1 to the power 7.
Mm-hmm.
X to the power 1. AC2 and 1 to the power 6, x to the power x squared. AC3 and 1 to the 5, x cubed. Do the powers always add to equal the original power?
Correct. And that's a good way to check the thing. Why do you not go to the next one?
Because it's only in terms of x cubed.
Yes. So they do that all the time. It's usually x squared or x cubed.
Yeah.
So this first one is gonna be 1. This second one is gonna be so if I put this in the calculator, I'll get 8. So what am I writing down here?
Plus 8.
X to the 1.
X.
Yeah. Plus, so this one I'm gonna have to check. Wait. 8 shift C2 times by 1 won't change anything. So that's gonna be 28. So next one.
28x squared.
Squared. And then this one is 8C3. And so last one.
56x cubed.
Yeah, and I'm just not putting in the times 1
Yeah.
to the power of whatever. Okay, part A is done. Part B.
So, to calculate approximately. Not sure how you'd go about it.
So it's quite confusing. You see this up here, the one that we just did. If x was 0.1, 1 plus 0.1 would give you 1.1.
Yeah.
And so that's where
I was looking at C, sorry.
okay.
By substituting x equals 0. So do you just need to put 0.1 in where x is?
Into which one?
The equation we've just got, the 1 plus 8x.
Correct. So method mark is 1 plus 8. Wherever there was an x, replace it with a 0.1 in a bracket. and then accuracy mark, you put it into the calculator, and then part C. Oh, I better do this. 1 plus. Squared plus 56. Okay, 2.136. Let me just check some. So that's our approximation. If I did it exactly, and I did 1.1 to the power of 8, and there you go. So our approximation was 2.136. Calculator says it's exactly, well, approximately, even the calculator. There's a better estimate is 2.14 and so on. So we're pretty good. How about C?
You substitute minus 0.1 in.
Well done. Yeah. So what do I write for the method mark?
Wherever there's an x, just put minus 0.1 in a bracket.
Yeah. Well, if I say minus 0.1. What about the squared? How do I deal with that? Is the squared inside the bracket or outside the bracket?
Outside the bracket.
Yeah, always. If it's inside, you'll get a negative. If it's outside, you'll get a positive.
Yeah.
Minus 0.1 to the 3, and then you just sub that in and get your answer.
Yeah.
And actually, because it's already in my calculator, can I do it? Probably very easy. Minus. There we go, 0.424. Any questions there?
No, that's all right.
Okay, so this bit looks very weird. That's all it's saying, that you can sub that in for x. 0.424 and 2.136. Great. These are exam questions. The top one you're okay for. How would you go about the bottom one?
So start off with 10C0.
Let me just copy this. Yeah.
And then the next bracket would be 1 to the, is that 10? To the power 10. And then it would be x over 2 to the power 0. And then 10C1, 1 to the 9, x over 2 to the 1.
So let's do this bracket. How do I deal with that in the calculator?
Is there not a... Oh, sorry. Which do you mean? Do you mean x over 2?
Yeah, so the 10C1 isn't too bad.
Yeah, no, well, there's a button in there in the top left, is it? Where you can put... Oh, you have to convert it into index file.
What would it be?
X to the minus 2.
No. Where was it? So I probably didn't put it. So the way we dealt with these here was I'll go to this one. The way we dealt with this was we just put in minus 2 without the x.
Yeah.
And then we just kind of figured it out. So what would I put in here?
I'm not sure, because if you take the x away, isn't it just the denominator?
Yes. So what's dividing by 2 the same as?
I'm not sure.
When do you divide by 2?
When you're halving.
Correct. And so that's the same as a half times a half.
All right, yeah.
Divide by 2 is the same as times by
Yeah.
a half. Another way to write this isn't x to the minus 2, it's a half x.
Right.
And that's how you'd go about these ones. That's 5. And so this first one will be 10. What will be the next one?
Just 1.
This is what my calculator said.
1.
So first term is 10.
Yeah.
Second term?
1 to the 10. Just 1.
So see this first thing up here?
Right, yeah.
That's 10. So then this, what's this one down here?
5.
Is that it?
No, 5. I'm not sure what to do with a half x.
We just remove, well, it will be x to the power of what?
1.
Yeah, and so it's just x. So what you could do, if I was to rewrite this, so x over 2 is the same as a half x.
Right.
So we just put in a half in the calculator without the x, and then we just put the x back in.
Okay.
So what will be the next term? How do you get next term?
10c to 1 to the 8. Half x to the 2.
X to the 2. I changed that a little bit.
2.5 x squared.
And I wouldn't try to do any of it in your head.
Yeah.
Just let the calculator do all the work. And
11.2.
so what goes here then?
11.25 x squared.
That's it. So you take the x out, put it back in. So I think the big thing there is that x over 2 is the same as a half x.
Yeah.
They wanted that the first 4 terms, so we could get the third term. How would we do part B?
No, I'm not sure on that one.
So for our previous one,
Yeah.
it was 1 plus x equals 1.1. So this 1 plus x is equal to 1.1. And so you just solve for x. Now they actually gave us x. So how would we get the x for this one?
Don't know. I'm not sure.
These two match up.
Right.
And so 1 plus x over 2
is equal to 1.005.
Yeah. What would you do to get x?
Carry the 1 over.
Yeah. And
So that's just 0.005.
Yeah.
And then times through by 2.
Yeah. 2. And so x equals 0.01. And then
put it into the equation.
that's it. Then you sub that in. So part B, 10 plus 5, 0.01 plus 11.25, 0.01 squared plus 15, 0.01 cubed. Put the whole thing in your calculator. So that's your method mark. Put the whole thing in your calculator, accuracy mark. Yeah, so these brackets, that to the 10, that to the 10, those two match up, and so those must be equal to each other. Basically, you use part A to do part B. Any questions there?
No, that's all right.
Okay, so this is the tough binomial expansion questions. So you put that in your calculator. Let's just take a look. They put in 0.01 as well, and they got the same expansion. Okay, and that's the answer you end up with in the calculator. Okay, this thing. How many different ways can you order these letters?
$16.
I believe. So how many letters can you choose for the first one?
4.
And once you've chosen that, how many letters for the next one?
3.
Once you've chosen those, how many for the next one?
2. And 1.
Yes. And so I believe you get 24 in total.
Yeah.
How many arrangements will there be for this one?
I can't quite see the end of the question, so.
Sorry.
5 times 4.
Yeah.
Times 3 times 2 times 1.
Yeah.
5 times 4 is 20.
That's all right. I think it's 120.
Yeah.
If we go to our calculator, 5 factorial, it's a exclamation mark.
Yeah.
5 factorial, and that's 120. And that just means 5 times 4 times 3 times 2 times 1.
Yeah.
Our 4 factorial was 24, I think. Yeah, so that's all it means. That's the number of arrangements. That's called factorial. That's 9 factorial, and so on. How many arrangements are there for these letters?
Would it be 24 again? Or?
So it should be 24. The trick, though, is that A and A, if you swap those around, it'd be the same thing. And because of those two, you have to divide by 2. You get half the number that you would have gotten.
Okay.
So you'll get a total of 12. Let's take a look. So if you call it A1 and A2, you can see how A1 and A2 will be the same as A2, A1.
Yeah.
BC. But there's actually no A1 and A2. They're just A and A, and so you'd have to half it. How about for these?
Would it be 120 divided by 3?
I'll just do 5 factorial. Yeah, 120. All right, I'll just leave it as whatever, 120. As we know.
So it would be 5.
However, you see these 3 A's?
Yeah.
How many ways are there of arranging those?
Only 1.
Now, if it was A1, A2, A3, how many different ways?
6.
So this time you're dividing it by 6. And so what we did a second ago, dividing this by 2, what we actually did was 4 factorial over 2 factorial. And it's just that 2 factorial is the same as 2. For this one, there's 3 different A's. And so there's a total of 6 different ways of arranging them. And so this is the same as, there was 5 in total, 5 factorial, and you have to divide by 3 factorial.
Yeah.
So this is total letters. And then on the bottom is the repeated ones, number of repeated. And if you do this for long enough, it produces a formula. Hang on. How about this one up here?
6 factorial over 3 factorial.
Yeah, so you've got the idea there. Okay, how would we deal with this one?
Is that 7 factorial divided by 4 factorial, 3 factorial.
So it's basically times. Yeah, that's how it works. That gives you this. And so this is the formula you end up with. Let's see. So n minus 1, n minus 2, because they go down by 1 each time.
Right.
Sure. And then this is the formula that you end up with. There's a better formula that you'll see in a second. But this is just where it comes from. And yes. So if you put into your calculator, let's say 7C3, C3, you get 35. And if we do 7 factorial over 3 factorial, was my one different? Is it over 4 factorial? Oh no, over 4 factorial, 3 factorial, is it? Yeah, sorry, over 4 factorial times 3 factorial. There we go. What did I do wrong? Times 35 as well. Yeah. So 7 choose 3 is the same as 7 factorial over 4 factorial times 3 factorial. And so that's where that choose thing comes from. It shows you all the possibilities.
Yeah.
Okay. These you can, so what would you put in your calculator to do the first one?
9 choose 3.
And what would that be written the long way?
9 factorial, yeah, over 4 factorial times 3 factorial.
It won't be times 4.
Times 2 factorial.
No. So there were 9 letters in total.
Right. Oh, yeah, so you got to make 9. 6 factorial.
Yeah. And sometimes you have to do some questions like that where you have to prove it. This one. Okay. That's okay. How many arrangements? Yeah. So this one you will just put. And here is the better formula. And we'll use that in a minute. Find the coefficient of y to the 4. Okay, how would you do this question? Any way you like.
Can you just move it down again, sorry, please?
Oh, sorry.
Cheers. Expansion of 1 plus coefficient. You start off with 9 choose, or 9C 0.
So you could, so 9C0, yeah, go on.
And then 1 to the 9, and then 3Y to the 0. Is that the long way?
And would you be able to skip down to the one that we need?
Yeah, so the 3Y would be 4 to the power 4, would it?
Mm-hmm.
So the 1 would be to the power 5. And it would be 9C 9C4.
Yeah.
Would it?
That's 0 and that's 0. They both start from 0. Yeah. And so that goes in your calculator. Shift C 4, 1 to the 5, and how do I deal with the last bit? It has a Y in it.
Just take the Y out.
Yeah, so 3 to the 4 and 10206. So that will be Y to the 4.
Yeah.
But they just asked for the coefficient, and so the answer is just 10206. Any questions about that?
No, obviously it's alright.
So there it is, 10206. The first 4 terms. Let's just see. Find the value of that to decimal places. Okay. How would you do 2A?
The expansion of. So I'd start off with 10C0.
Would you need it?
Well, no, it's just
If you want,
help
yeah.
to see
Yeah, okay.
what I need to skip forward to. And then 1 to the 9.
No.
1 to the 10, sorry, and X to the 0. And then I'd go to 10C5. And then it'd be 1 to the 5 as well, and X to the 5.
Yeah. To the 5, and then you just put that in your calculator without the X. I think I can get away with just putting in 10C5 because it's times by 1. 252. Use the binomial theorem to find the value of 1.03 to the power of 7, correct to 2 decimal places. Let me just go back a second. This is the binomial theorem. So let's try using this.
Is that not what we've been using though? Is this new?
It's yeah, that's what we've been using. It's just a different way. Okay.
Right.
So that's all right then. I'm happy there. Okay, this is this. Use your expansion to 4 decimal places. That's exam question. I think you're good for that. Good. And then we have this. So this is okay. How would we do this one?
The coefficient of X to 5. The binary function. Oh. So I'd go 9C5. 6 to the power 4, and then 1/3 X minus 1/3 X.
Well done.
To the 5.
And yeah, I think you're good. Shift C5, 6 to the 4, and then just put it in with the X. Oh, close bracket. To the 5, minus 672. 72. You can see there two marks. So this is the method mark, this is the accuracy mark. So the book showed like 6 to the power 4 what that is. You don't need to do any of that.
Yeah.
Not worth anything. Minus 672. Okay, we're good. Minus 672. Find the coefficient of X to the R. I'm going to leave that. I created that question. We might not need it. Okay, this is a good one.
In this expansion, oh, yeah. Given in this expansion, twice. You just start the same way we started every other one.
Yep.
Okay, so 5C. 5c2
Okay.
for x squared.
Mm-hmm.
To 3 to the power cubed, 3 cubed. Bx squared.
So how do I deal with this?
You just have to do 5c2 and then 3 cubed.
Yeah.
And leave out the bx.
So that's 270. What would you do next?
Divide by 2. Oh no. Yeah, divide by 2.
And what would go after this 270?
Bx.
Not x.
Just it would do. Oh, bx squared.
Yeah. And don't forget, squared means times by itself.
Yeah.
And so bx times bx, it gives you x squared. It also gives you b squared.
Oh, right.
They're in a bracket, so it's both of them squared.
Yeah. Yeah.
If that was 3x, it'd be like 9x squared. Okay. So what is the coefficient of x squared?
270b squared.
Yes. Okay. What is next?
To divide that by 2.
What would be the coefficient of x?
B.
So if you did it the whole thing.
No, I'm not sure.
So coefficient of x would be like that.
Right.
Middle bit?
5c2.
No.
x1. No, I've got no idea.
5c1.
Oh, right. And then 3 to 4.
Yeah. Okay, so this one, very similar. I put that in wrong, did I? I put in cubed, I should have put in squared. 5c2 times 3 cubed. Sorry, 270 as well, is it? I got lucky. 5, it's quite common that happens. 5c1, 3 to the 4. 405. So this will be 405 what?
bx.
X. Okay. So now what are we doing?
Is that not the coefficient for 405b?
Yeah. So that's the coefficient of
find
x.
the value of b. Find the value of b. 2 and would you put the top, the 270b squared x squared equal to 405 bx?
So 270b squared is equal to 405b. However, they said the x squared is twice bigger. So if I did that, it would have to be like greater than. So how would I make them equal?
Would you have to get rid of the squared?
You would do what you were saying at the start, which is dividing this one by 2.
Right.
So half of it will be equal to it. So 270 divided by 2 is 135. So
Okay.
it's twice as big, and so when you half it, it's equal. And so 135b squared is equal to 405b.
Okay.
And then what would you do?
And then you're trying to solve for B.
Yeah.
So, would you get rid of the squared?
How?
Square root the other side.
I think what I would try is to divide both sides by 135. That might not work, but if I divide that by 135, there you go, 3. Brilliant. So if you divide both sides by 135,
B squared equals 3B.
yeah, okay. Now how do we solve this?
Well, then would you do the square root the other side, or could you not do that? No. I don't know, because there's 2 B's in there.
You have a quadratic. How do you solve a quadratic?
Factorize.
Yeah, first you make it equal to 0.
Right, so
and then you factorize.
3B. So, it'd be first in the bracket. B. Minus, and then B minus 3.
That's it. So solution.
So B equals 3.
So B equals 3. Yeah, because otherwise it would be B equals 0 or B equals 3, and it can't be 0 because it has to be twice bigger.
Yeah.
Yeah. Any questions about that?
No.
Okay.
No, it's just a bit more difficult to get my head around.
Yeah. So you're using the same ideas. You're now just getting the coefficient in terms of algebra. So you're getting the coefficient with a letter, and then you're solving that letter. So you have to work in reverse. So B is 3. They did something similar. And let's just take a look at this one. The first 4 terms are given below. Estimate this. So I think that's exactly the one we previously did, or very similar. Okay, so I just want to look in the book Binomial. Solving binomial estimation. Okay, binomial expansion. So I'm just making sure that, because the A level recently changed, I'm just making sure that I haven't left anything out. So there's no exam questions for section A. So here's some exam questions for section B. So they look a bit weird. Let's make sure. And so the ones we did there were past exam questions, so you can see how it's quite common that they do that one. Expand the first 3-4 terms, then estimate, then go there. Okay, exam question. What is this? Question 10.
Given that. Right. Is it? That's the same as writing 50 choose 13. Is it?
Yeah. And so what number is it?
A would be 37.
Yep, that's it. That's all there is to that. How about this one?
It's P 17.
P is 17. That's all that is. So those are 2 1 markers. So that's section B. Let's see, section I'll just take a look at these. Question 5, find the first 3 terms of this. So we did those. Question 6, find the first 3 terms of this. We did that. And this one, find the binomial expansion of this, giving each term a simplest form. So I've never seen this one before. And it does look like it's, you know, the most challenging of this section.
Yeah.
Okay, so how are we doing this one?
5C0
Mm-hmm.
x to the do you not need a power? Sorry, 5C0.
Yeah. So what is the power?
5. And then 1 over x to the 0.
Yeah. And so what would I put in the calculator for this first one?
5C0. And then is it just 1 over x? Is you get rid of the x?
And then times 1, or yeah. So that's just 1. So what do I end up with here?
1x to just x to 0. Just x.
What is anything to the power of 0?
Just 1.
Yeah. So that's going to be, so the coefficient was 1 times something times 1. What is the middle one?
X to the 5.
Yeah. So what is that?
Times x to the 5. Just x to the 5.
That's x to the 5. Okay, second one.
5C0.
No.
5C1, sorry.
Yeah.
X to the 4.
Mm-hmm.
1 over x to the 1.
Yeah. So what goes in the calculator for this one?
5C1 times 1.
Okay, so 5C1 is 5.
Times x to the 4. Times 1.
Well, this one is 1 over x to the power of 1.
Just 1 over x.
Yeah. Simplify that.
5x to the 4.
Well done. No. 5x to the 4. Go
on. Times by 1 over x, but I'm not too sure what that'd be.
That would be x to the 4 over x.
Right.
And so what is x to the 4 over x?
X to 3.
Yeah. Okay, next one.
5C2 x to the 3. 1 over x squared.
Mm-hmm.
So it'd be
Hang on. 5C2. So that's 10.
Times x to the 3. Is that 2 over x squared?
What's 1 squared?
1.
Yeah, basically it's 1 over x times 1 over x.
Oh, right.
Yeah.
So 1 over x squared.
Okay.
Squared. So that was 1. Is that 10 x to the 10x.
Yeah. Next one.
5c3.
Mm-hmm.
How do you know when to? Oh, right. We're going up to 5.
We won't go up to 5. This last one is the one I want to check.
All right. 5c3x squared. 1 over x to the 3.
Mm-hmm.
And then that's whatever 5c3 is times, is it 15?
10 again.
Right, 10 times x squared. So that is 1 over x cubed. Would be, is it x squared over 3?
So you've got x squared over 1 times 1 over x cubed.
X squared over 1. Is that just x squared over x cubed?
And can you simplify that?
Yeah, x to the minus 1.
Oh, well done. Okay, so 10x to the minus 1, or just 10 over x would have been fine.
Yeah.
Yeah, and so that one is the hardest one, and they'll keep going that way, where you'll get negative x's as you go. So you just continue that for the 4 and then the 5. Any questions there?
No, that's good.
Okay, so the negative stuff is the difficult. So you can see there, exam question 5 is the type we've done a lot of. 6 is the type we've done a lot of, and so 7 is like the most challenging of that section. Solving binomial problems. Find the coefficient. So we did those. 1 minus 2x to the p is expanded. The coefficient next to it is 40. The constant of p, the coefficient. So those are the coefficients, okay. Oh, lots of exam questions for that. Hang on. Then find the first term and then use your thing to estimate. So we did lots of the thing for estimating, and then it's mixed. So it looks like there's lots of exam questions for this one. So you can see here, yeah, this is 29 times the coefficient of the other one. Let's just do this first one because I don't really recognize it. It might be the same. Okay, what is this? Well, is expand the coefficient of x squared is 40. Okay, how do we do this?
Find the value of the constant. Would it be PC 0?
For the coefficient of x squared?
PC 2. And then 1. That'd be 1 squared, would it? Oh, I don't know.
No.
To the power p.
That would be the first one. So let's just do this power. So it will be this one.
Minus 2x. That'd be squared.
And so what did we say about the 2 powers?
They have to add to make whatever p is.
Yeah. And so what would this one then be then in terms of p?
P plus 2.
That would make p plus 4.
Right.
Needs to make p.
No, I'm not sure.
P minus 2.
P minus 2.
Yeah. So make p minus 2 plus 2 will make just p, or p plus 0.
Sorry.
Okay. What is this? Oh, so the coefficient of x squared is 40. What is minus 2 squared?
Minus 2 is 4.
So that's going to be 4. What is 1 to the power of anything?
Just one.
So it'll be timesing it by 1. And so it'll be 4 times P choose 2 gives you 40. Anything you can do there?
The coefficient of x squared. Could you divide through by the 4?
Yep. What would you get?
Just 10.
So P choose 2 is 10. How might you figure that
out? P choose 2 is 10. No, I'm lost now, sorry.
I would just use a calculator.
Yeah.
I know off the top of my head 2 choose 2 is going to be 1. That's the way that always works. And in fact, cheat time table. Alpha x shift choose 2. So something choose 2. I'm going to start with 1. Start with 2 because that's the lowest it can be.
Yeah.
Let's say end at 10. And do I get a 10 anywhere? Yeah.
Yeah, there's a 10 there.
So what is P?
I can't quite read it, sorry. Is it 6?
5. Yeah. So P is 5. I mean, you'd literally, if you didn't want to do it that, I didn't know it would be that simple. But
Yeah.
If you were just doing it a normal way, I would just do, 3, choose 2. That didn't work. Needs to be a bit bigger. 4, choose 2, and so on.
Yeah.
Yeah. So that's, any questions about that one?
No, that's all right.
So now that we know P is 5, so it's just 1 minus 2x to the 5. And then you just do as normal. Find the coefficient of x. 5, choose 1, and so on. Minus 2x to the 1. And same with the x cubed. And we've already done those. Yeah, so we've done at least one of every type of exam question, and including these ones, which are the new bits.
Yeah.
Yeah, how was that for you, Conall?
Good, yeah, I feel a lot more confident about it with expansion.
Anything in particular you want to do next time?
Not off the top of my head, no.
Okay, well, you
Is there
can
anything that follows?
Not that I can think of.
Differentiation, actually.
Okay, differentiation is a good one. It's a big one.
Yeah, and then integration after that.
Okay, and so you'd probably need, like, you wouldn't be able to do both in one, but yeah.
Oh, no.
Yeah. Okay, any questions for me in general?
No, that's it.
Okay, well done, Conall. You did great. I look forward to
Cheers,
chatting again next week.
I'll see you next week.
All right, have a good one. Goodbye.
You too. See you later.